So today we're going to look at being able to determine the absolute minimum and maximum values versus local minimum and maximum values. So there's a subtle difference. We're still going to be using our first derivative to determine critical points, but now we'll have to look at something else to determine what's absolute and what is local. All right, so we have a graph here. You can see it's on the interval from 0 to 5. I'm going to scroll down a little bit. So we actually have endpoints. In a lot of the other graphs that we've looked at, they've just had a domain of x as an element of the reals. In this case, we now have endpoints that we need to consider. So I'm going to start off by answering question A, which is identify the local minimum and max. So the local min is here, and our local max is going to be located right here. So we find those values using the first derivative. Now the next question says, are the values, oh, there's a little typo here, absolute extreme values, explain. So when I look at that graph, the word absolute means there's nothing bigger or nothing smaller. Extreme just means minimum and maximum. You'll see this word, or extrema or extremum. They all mean the same thing. It's all about minimum and maximum values, whether they come from the first derivative or they are endpoints. So the answer to this question is no. The endpoints represent the absolute min and max. So these are going to be local. So I'll just put that word out in front. And this one here would be an absolute min, because there's no other value smaller than -8. And here we have an absolute max at 4.5. So while we're doing this part now, we're really going to have domains that we need to think about. So you have to think about the endpoints and whether or not they are higher than some of the values that we get from the derivative. So here's a typical question. Determine the absolute max and min values of the cubic function given for the domain -3 is less than or equal to x, which is less than or equal to 4. So I'm going to start the question the same way. I see the word max min. I'm going to solve my first derivative when it's equal to 0, but first I need to find it. So I have 3x squared minus 12. So I substitute in 0 because min and max occur when the slope of the tangent is equal to 0. So I move the 12 over, equals 3x squared. Divide both sides by 3, I get 4. I square root both sides, I get plus or minus 2. Don't forget that plus or minus. So what I'm going to do now is I'm going to evaluate and determine what the points are at 2 and -2. So f of 2, I'm going to substitute in. So f of 2, we get -19. F of positive 2, we get, oh sorry, this one should be negative. At -2, we are going to get 13. So if I were to stop right now, clearly the f at -2 is a maximum value. The f of 2 at -19 is a minimum value. However, we also need to consider the endpoints. So you also got to consider f of -3, which is going to give you a value of 6 when you substitute into the original. And then f of 4, which gives us 13. So to determine absolute mins and max values, you're looking for the highest value and the lowest value. So when I do that, this is going to be the absolute min. And then we have two absolute max values. So this is an absolute max. And then this would be an absolute max as well. So you can have more than one. And we would call this one a local. And right now I'm not sure if it's a minimum or maximum value based purely on the derivative, because I don't know if it's switching from increasing to decreasing or vice versa. All right, so here's another type of question. Can we determine the absolute min and max values for the functions below? Explain. So I have a rational expression here. So in A, there's going to be an oblique asymptote. There's also a vertical asymptote at, oops, I didn't want to do that. So vertical asymptote at x equals 3. So you always want to look at your domain once again. So that's the restriction that we have. X cannot equal 3. When I look at 3, 3 is within the domain. So when I have this particular graph, the fact that there's a vertical asymptote within our domain, so if you picture any vertical asymptote, so I'm just going to sketch this one right here, and I'm not sure what's going on with this one, but let's say it's approaching positive infinity and negative infinity. Will there be an absolute min or max value? The answer is no. So for this one right here, it's no, since the vertical asymptote is within the domain. All right, now this one over here, once again, we are going to have vertical asymptotes at t equals plus or minus 2. If I look at the domain, it's from 5 to 10. So the answer to this one here is yes, since the vertical asymptotes are outside the domain. So then we would proceed by finding the derivative, solving, and checking the endpoints, just like we did in the previous example. So the last one we're looking at right here. So once again, our domain, there's a vertical asymptote at x equals negative 3. Negative 3 is outside the domain. So yes, since is outside the domain. So the big thing with this particular lesson is just the fact that now you have to consider domain, which is going to become important when we start looking at optimization problems. The domain is very important for a lot of those questions, since some answers are not going to make sense in context. The other thing we wanted to talk about is something called, well, first of all, here's sort of a little summary. Determine all values in the interval that f prime of x is equal to 0. Find the endpoints, and then you're going to compare the values to see which one is the highest and which one is the lowest. So that's just a little summary. Now, in curve sketching, we never actually did the second derivative test because we used tables to be able to tell this information. However, to determine if something's a minimum or a maximum, you don't always want to have to do a table. Sometimes it might be quicker just to do the second derivative and figure out if it's a minimum or a maximum. So if we're picturing the derivative is equal to 0, and it's telling me that the second derivative is greater than 0, so that means that it's positive, so it's concave up. So if I picture concave up, this is the shape that we have. That's always going to give us a minimum. If it's equal to 0, and the second derivative is less than 0, we're concave down. So concave down, we have our frown. Then we're going to have a max value. If if the second derivative is equal to 0 and it changes sign, then there's going to be a point of inflection. So if you find you get 0 from the first derivative and 0 from the second derivative, it's likely going to be a point of inflection. So that's a summary of the second derivative test. So if you ever see somewhere where it says determine without using interval tables if the value is a minimum or a maximum, you can use the second derivative. So here's an example. Determine the critical points given that function. Use the second derivative to determine if they are minimum, maximum, or neither. All right, so I'm going to start off with f prime. So we get 6x squared minus 10x, and the derivative of 4 is 0 since it's a constant. So we have 0 equals, I'm going to factor out a 2x. So 3x minus 5. So I solve for my zeros. So x is equal to 0. and the other value is x is going to equal 5 over 3. So right now I know that at f equals 0, we get 4. If you substitute in 5 over 3, we get negative 17 over 27. So I know I have two critical points at those values, but I want to know if they are minimum or maximum. So in order to check that without having to do an interval table, I am going to find my second derivative, which is 12x minus 10. Oops, should be a minus, not an equal. I'm going to sub in my x values. So f double prime of 0, when I put that in, I get a negative 10. So therefore, that means it's going to be concave down. So therefore, 0, 4 is a max, because we have concave down shape. If I do the same thing with 5 over 3, so I'm going to have 12 multiplied by 5 over 3 minus 10. We get 10. Therefore, that's going to be concave up. Therefore, the point 5 over 3, negative 17 over 27 is going to be a min. Now, I haven't stated if they are local or absolute because there's no given domain. So at this point, there's no reason to do that. Hopefully this makes sense and is fairly straightforward. But as always, if you have any questions, please email me or ask me.